But once this folder is loaded, we already have everything. I mean, what am I talking about? I forgot. Anyways. Okay, it's a really horrible model, I think so. Trajectory. I don't think it's an English word. Which will be the original position from which we will send these balls. Welcome back everyone. In this video I'll teach you how you can create a snowball gun in Roblox Studio. And as you can see, I moved my position a little bit. I mean, it's the same position, but I just rotated my table and I added this lightning, and I hope you like it. So don't forget to support, press like, subscribe to the channel, and let's get started. So first of all, we need some sort of a model for our gun, and I don't really want to spend so much time modeling the gun, so I'll just create it using two parts. So this will be our handle, and this thing will contain snowballs, I guess. Okay, it's a really horrible model, I think so, but it will probably work out, like why not. So I'll name this handle a handle, and I will connect it to this thing using a weld constraint. So I'll set part 0 to handle and part 1 to the second part of the gun. Then I'll create a tool in workspace, and I will move these parts inside of the tool. Okay, so I think right now we should be able to pick up this some sort of gun. Alright, so it's a little bit buggy, but we can fix it. So I will select our handle and I will move it to 90 degrees to any of the sides. I don't know which side is correct one. Okay, it was not correct. So I should rotate it by 180 degrees now. And I also want to resize it a little bit. Let's try again. And okay, it works well. So now I will select this part. I'm holding Alt key and clicking to this part. And now I want to create an attachment there. And I will move this attachment to this part of this part. So it sounds very confusing because I don't know how to call this thing. I'll call it a pipe. Alright, so this pipe has an attachment, and we will use the attachment's position to throw snowballs from. Okay, so now we can actually move this tool to starter pack. So now when we start the test, we already have this tool in our hitbox. I mean, not hitbox, but hotbar, or our inventory. So now we should create a model for our ball. So I'll insert a sphere, I'll resize it. Okay, it will have a snow material, and I will move it to replicated storage. So replicated storage is just a, it's just a storage. We can store here anything we want and then use it later using scripts. So I'll rename it to snowball, and now we came to scripting part. So we will use local script, we will use server script, and we will use remote events. So I'll explain how it works. So right now we should create local script inside of the tool. We're gonna use this local script to detect when the tool gets activated. So now we're getting the tool, we're getting an activated event, and we're connecting a function to it. So this function should trigger remote event. So right now I'll create folder inside of replicated storage. I'll rename it to RemoteEvents, and I will create a remote event inside of it and name it Fire Snowball, or just Fire, because why not? We will keep things simple. I'll create a variable for it, so Fire event equals to game replicated storage wait for child remote events and fire. So now here I will fire server using this method, and using this remote event. So that's all for local script for now. And now I'll create a server script. We should also get remote event inside of it. So fire event equals to game replicated storage, remote event, and fire. So I'm not using wait for child here because it's server script and everything is preloaded here already. And we should wait on local script. I mean, we should wait on client side because different players have different ping, and you know, it can take some time to load this folder. But once this folder is loaded, we already have everything. I mean, what am I talking about? I forgot. Anyways, so let's get back to this fire event and use this on server event signal. I mean, an event. So we're connecting a function to it, and we already have a player who sent this request using remote events, and we should also send a position and I guess something more. So let's get back to client script, local script, and we should get a camera. And now we're gonna use this camera to get a mouse cursor position on the screen. So we're gonna use this position to calculate the trajectory for snowball. So I'll create a function called calculate trajectory. I don't think it's an English word. I don't know what else. Calculate flying direction. Flying direction, maybe. So now I'll create a ray variable and set a camera screen point to rate. Screen point to ray. So we're gonna write it so, and we should pass an x and y arguments inside of this method. We can also pass the def argument, but it's optional. We can see the question mark right here. So we should get an x and y. I'll use mouse. I'll use the player's mouse to get the x and y. So game players, local player, get mouse. And now here I simply write mouse x, comma mouse y. So we just got the ray, and I'll rename this function to calculate get ray. Okay, anyways, and now I just return ray origin and ray direction. So here I'll have origin direction equals to get ray, and I'll pass this origin and direction to this remote event request. On the server side I'll have also two more arguments, so we should get them. The first one will be origin and the second one will be direction. And I forgot about the last one, which will be the original position from which we will send these snowballs. So we will create a variable, I think original position maybe, or starter position equals to tool pipe attachment position. So this is why we created the attachment, and I will send the starter position to the server. So starter position. So now we should create the I think we should clone the snowball. So we're gonna have a variable for snowball. I'll create a snowball template equals to game replicated storage snowball. Here I'll create a variable snowball clone equals to snowball template clone. Then I will set the position to starter position and snowball clone velocity. It is actually deprecated, but I guess we can also use assembly angular velocity or assembly linear velocity. We're gonna try this, but to be honest, it didn't work for me before, but we can try it now. Okay, I'm not sure about the formula right here, I forgot it a little bit, But let's finish the setup for the clone and then we're gonna play around with this formula. But I'll actually cut this part and tell you which formula works. So now we should parent the snowball to workspace, and we don't want the snowball to live forever. So we're gonna use debris service in order to remove the snowball clone after, let's say, 5 seconds. Okay, let's try it. Alright, we have snowballs, but the formula is incorrect. Okay. Okay, I'm still working on this formula, but I just changed the attachment position to attachment world position, because the simple attachments position is, I think, always set to 0. I think so. But the world position is literally world position, and we actually need it. So I'll just change the position to world position. Keep in mind. Alright, so I just fixed the formula and here it is. I mean, I also made some changes right here. So I return the normal origin, but I also added unit to this direction. To be honest, there's some kind of maths. I'm not really sure how it works, like the units stuff. This is how ChatGPT actually told me, but yeah. So I'm not good at maths, sorry. So this is what change I made here, and I also made some changes right here. So I'm using assembly linear velocity, and it equals to direction unit multiplied by 500. 500 is the power of the throw of the fire itself. And actually we don't need this origin right now, so I can remove it here. I can remove it right here. Like this. So if we start the game and fire the balls, and you can see it actually lags a little bit, and it's very annoying. At this point I want to stop the video because it's already 12 minutes long, so I just decided to split this video into 2 parts. Right now you usually saw the first part of the video, and the second part of the video I'll drop on Thursday. So in the second part of the video I'll optimize the shooting progress or the fire itself. I'm not actually sure how to call it, but we will make an optimization for this gun. So right now it just works, but in the second part we will make an optimization. So I don't want to make this video 20 minutes long, you know. Okay, so this is it for now, so wait until the second part, and don't forget to support. Press the like button, subscribe to the channel, write comments, and yeah, thanks for watching, see ya!